Fourier and related algebras occur naturally in the harmonic analysis of locally compact groups. They play an important role in the duality theories of these groups. The Fourier-Stieltjes algebra and the Fourier-Stieltjes transform on the Fourier algebra of a locally compact group were introduced by Pierre Eymard in 1964. Definition: informal. Let G be a locally compact abelian group, and the dual group of G. Then the Fourier transform of functions in L1 G caret display style L_1 wide hat may that G closing curly bracket the group algebra of G caret display style wide hat may that G closing curly bracket is a subalgebra A G of CB G, the space of bounded continuous complex-valued functions on G with pointwise multiplication called the Fourier algebra of G, and the Fourier-Stieltjes transform of measures in M G caret display style M wide hat may that G closing curly bracket the measure algebra of G caret display style wide hat may that G closing curly bracket also a subalgebra of CB G called the Fourier-Stieltjes algebra of G. Formal. Let B G display style B may that G closing curly bracket be a Fourier-Stieltjes algebra and A G display style A may that G closing curly bracket be a Fourier algebra such that the locally compact group G display style may that G is abelian. Let M G caret display style M wide hat may that G closing curly bracket be the measure algebra of finite measures on G caret display style wide hat G, and let L1 G caret display style L_1 wide hat may that G closing curly bracket be the convolution algebra of integrable functions on G caret display style wide hat G, where G caret display style wide hat may that G is the character group of the abelian group G display style may that G. The Fourier-Stieltjes transform of a finite measure mu display style mu on G caret display style wide hat may that G is the function mu caret display style wide hat mu on G display style may that G, defined by mu caret x equals G caret x x d mu x x G display style wide hat mu x equals int_ wide hat G over line x x closing curly bracket backslash d mu x quad x in G. The space B G display style B may that G closing curly bracket of these functions is an algebra under pointwise multiplication is isomorphic to the measure algebra M G caret display style M wide hat may that G closing curly bracket restricted to L1 G caret display style L_1 wide hat may that G closing curly bracket viewed as a subspace of M G caret display style M wide hat may that G closing curly bracket. The Fourier-Stieltjes transform is the Fourier transform on L1 G caret display style L_1 wide hat may that G closing curly bracket, and its image is by definition The Fourier algebra A G display style A may that G closing curly bracket. The generalized Bochner theorem states that a measurable function on G display style may that G is equal almost everywhere to the Fourier Stieltjes transform of a non-negative finite measure on G caret display style wide hat G, if and only if it is positive definite. Thus, B G display style B may that G closing curly bracket can be defined as the linear span of the set of continuous positive definite functions on G display style may that G. This definition is still valid when G display style may that G is not abelian. Helson-Kahani-Katznelson-Rudin theorem. Let A G be the Fourier algebra of a compact group G, building upon the work of Wiener, Eliacute v.y. Gelfond, and Berling. In 1959 Helson, Kahani, Katznelson, and Rudin proved that, when G is compact and abelian, a function f defined on a closed convex subset of the plane operates in A G, if and only if f is real analytic. In 1969 Dunkel proved the result holds when G is compact and contains an infinite abelian subgroup. References: Renaud, Jean. 2001. Fourier algebra. 2. Quote. In Hayes-Winkel, Muschiel. Encyclopedia of Mathematics. Springer. ISBN 978-1-55608-010-4. Functions that operate in the Fourier algebra of a compact group. Charles F. Dunkel, Proceedings of the American Mathematical Society. Volume 21. No. 3. Jun. 1969. pp. 540–544. Stable URL. 1. Functions which operate in the Fourier algebra of a discrete group. Leonid de Michel. Paulo M. Sordi. Proceedings of the American Mathematical Society. Volume 45. No. 3. September 1974. pp. 389–392. Stable URL. 2. Uniform closures of Fourier Stieltjes algebras. Ching Chu. Proceedings of the American Mathematical Society. Volume 77. No. 1. October 1979. pp. 99–102. Stable URL. 3. Centralizers of the Fourier algebra of an amenable group. P. F. Renaud. Proceedings of the American Mathematical Society. Volume 32. No. 2. April 1972. pp. 539–542. Stable URL. 4.